talk about 8.2, multiplying and factoring. So what we're going to start with is multiplying, and we're going to take a monomial, which is one term, by a polynomial, which means we just distribute. When we distribute, I want to remind you, we're going to multiply the coefficients, keep the base, and add the exponents. It's really just that easy. So here we go with example number 1. This is what you are doing for 9 through 14. I guess it'd be 10 through 14 because we're doing even. And 29 through 34. Or 30 through 34. All right. So maybe we have something like this. 6x squared times 4x squared minus 3x plus 2. So start off easy. So you have a monomial in front of a parenthesis, which means we have to distribute. So 6x squared times 4x squared. We multiply our coefficients, we keep our base, and we add our exponents. Now we go to the next one. 6x squared times negative 3x. We multiply our coefficient. 6 times negative 3 is negative 18. We keep our base, and we add our exponents. And then we have 6x squared times 2. Multiply our coefficients. We keep our base, and we add our exponents. Then you need to check and make sure it's in standard form, which means your exponents go in descending order. And they do. We have 4, 3, and then 2. Pretty easy, right? Okay. Here is example number 2. We're going to get it a little bit tougher. What if, so same problems, what if I had negative 2y to the third times by 3y squared minus 7 plus 4y times 3y to the fourth minus 2. Woo! All right, so we have that negative 2y to the third in front of the parenthesis, which means we have to distribute. Yes? Good. 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 Positive 14 what? Good. Excellent. All right, so we're done with that parenthesis because we're at the end of the parenthesis. Now we got to go to the next one. So I have 4y times 3y to the fourth. Again, I multiply my coefficients, and I add my exponents. 4y times negative 2 is negative 8y. Now, we got to check and see if we're in standard form. Our exponents go 5, 3, 5. Uh-oh. We got to collect like terms. So we're going to start with our highest exponent. I have this negative 6y to the fifth, and I have 12y to the fifth. Means I have? Perfect. 6y to the fifth. My next one is going to be positive 14y to the third. I don't have any y squareds, but I do have a minus 8y. Any questions? That's half the lesson right there. We don't have any questions on that at all? No. Awesome. All right, so let's talk about what I mean by factoring. Factoring means that we're going to undistribute. So we're going to do what we just did in reverse. So if I have, for example, how about 4x squared minus 8x? What I want to do is take out the biggest or the greatest common factor that is in both things. And I'm going to pull it out to the front. So I'm doing distributing backward. I'm taking it out instead of putting it in. Okay? So what's the biggest number that goes into both 4 and 8? 4, okay? And what's the most x's we can have out of x squared and x? Well, I can't take an x squared out of x, right? So just x. Yep. All right. So now, if I'm taking those out, this one is a 4 times x, right? If I'm taking out a 4 and an x, what am I left with? Just x. Good. Here, this is minus 4 times 2 times x. And here I'm taking out a 4 and an x. So what am I going to be left with? Yeah, minus 2. So you can see if I went ahead and distributed back in, I should be back to there, right? 4x times x would give me 4x squared. 4x times negative 2 would give me negative 8x. All right. There's example number 3. And this is problems 16 through 26. And the direction either says find the greatest common factor or factor. So it means the same thing. We're going to say find the greatest common factor, then factor. Kind of covers those. All right, so let's say I have something like 14 t to the third plus 21 t squared minus 7t. All right, what is the biggest number I can take out of 14, 21, and 7? Very good. We're going to take out a 7. And what is the most t's I can take out? Yep, just a t. Because I can't take anything more. The most t's I have is 1 t. Take any more and they're not there, right? All right. So if I take a 7 out of 14, I'm left with 2. If I take a t out of t to the third, I'm left with t to the second plus, if I take a 7 out of 21, I get a 3. If I take a t out of t squared, I have 1 t left, minus, now if I take a 7 out, I take a t out, what is left behind, you think? A 1. That magical 1 will always be left behind. That way, if I were to distribute it back in, I should be back to here. Let's do one more. Let's say I have negative 3x to the third minus 6x squared minus 9x. Now I'm getting tricky. What do you think we can take out of all three? What number? Negative 3, perfect. That is absolutely perfect, Maddie. Thank you. Because all of them, there's a negative there, right? We want to take out a negative 3. How many x's can I take out? Just 1x. Good. All right. In the first term, if I take a negative, a 3, and an x out, what am I left with? X squared. Good job, you guys. All right, in the next one, if I take out a negative and a 3 and an x, what am I left with? Positive 2x. Good. And in the last one, if I take out the negative, a 3, and an x, what am I left with? Positive 3. Good job, you guys. And again, you can quickly check by negative 3x times 3 would give me negative 9x. All right? Okay. Example number 4. Because you guys have everything else so good, we're going to go to this one. We have a circular table with a radius of 6x. Inside that circular table is a diamond with a side of 3x, so that's like a square on its side, right? I want to find the area outside of our square and inside the circle. I want to find this area right here. All right, so in order to find that area, what I have to do is I have to take the area of the circle and subtract the area of the square. So first of all, how do we find the area of a circle? Area equals pi r squared. You guys know that one, right? Okay. All right, so we're going to do the area of the circle. So this is pi, and then our radius is this line from the center to the outside, which is 6x, and that is squared, minus the area of a square. Well, how do you find the area of a square? Yeah, it's length times width, side times side. I'm not sure which way you guys were taught last year, you know what I mean? You were taught which way? Yeah, that's a circle. Pi times radius squared is a circle. Square. For the square on the inside, this piece. Length times width. Okay. So my length is 3x, and since it's a square, the width is also 3x, right? So this is 3x times 3x. All right. So let's kind of simplify this a little bit. I have pi times, the squared has to go to both, so 6 squared is 36, and then we have x squared minus, what's 3x times 3x? 9x squared, good, 9x squared. All right, so I've got to multiply this one by pi, so I have 36x squared pi minus 9x squared. Now, what can I undistribute out of both of those terms? What's the biggest number I can take out? 9. Very good. I can take out a 9. What is the most x's I can take out? 2. Good. So you have 9x squared on the outside. If I take a 9 and an x squared out of here, I'm going to be left with 4, and then of course the pi is still left behind. Minus, if I take 9 and x squared out of here, what's that magical number left behind? Perfect. So you have one problem like this. This is like number 28, hint, hint. And that's it.